Now, in this lecture, we'll find out the radius of the semicircle. In the drawing, we have a semicircle and the line segment PS cut the semicircle at points Q and S, and PA is tangent to the semicircle at point A. Point A is the point of tendency. In addition, you know that the length of line segment PA equals to 6 units. Line segment PQ equals to 4 units in its length. And we also know that angle PAB equals to 90 degrees, and this angle CQS also equals to 90 degrees. And finally, we also know that line segment CQ equals to line segment QS. Again, our mission is to find out the radius of this semicircle. So, first of all, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, in any circle, if AB is any chord in the circle and PT is tangent to the circle at point T, then the following equation is true, that PT square equals to PA times PB. Okay, again, PT is tangent to the circle at point T, and line segment PB cuts the circle at points A and B. Then, according to this rule number 10, the following equation is true: PT square equals to PA times PB. Actually, we can implement rule number 10 in our drawing. Why? Because in our drawing, we focus at point P, according to rule number 10, we know that PA is tangent to the circle at point A, and line segment PS cut the circle at points Q and S. Therefore, we can implement here rule number 10. According to rule number 10, we will get that PA square equals to PQ times PS. Repeat again. If we focus at point P in the drawing, we get that according to rule number 10, PA square equals to PQ times PS. This equation is the implementation of rule number 10 in our drawing. Okay. PA equals to 6, therefore PA squared is 6 squared, that is 36. And it is equals to PQ. PQ is 4 times PS. PS is 4 plus QS. Again, PS equals to PQ plus QS. That is to say, PS in total equals to PQ, that is 4 plus QS. So we substitute PS by 4 plus QS. Then PA is 6, therefore PA squared is 6 squared, that is 36, and it is equals to PQ. PQ is 4 times PS. PS is 4 plus QS. Here we'll divide this equation by 4, and we get that 36 over 4 is 9, equals to 4 plus QS. Here we'll subtract 4 from this equation, and finally we get that QS equals to 9 minus 4, that is 5. So actually found out that QS equals to 5 units in itself. So we can write here that Q8 is equals to 5, but because of the fact that QS equals to QC according to what is given as the equation here, QC equals to QS, and QS is 5, therefore QC that equals to QS must be also equal to 5 units in its length. In the next step, we join points P and C together by a straight line. It is given us in the question that PS is a straight line. So if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. Rule number 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. AB is a straight line, so if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. According to this rule, rule number 3, so which angles we have at the upper side of AB at point Q, we have this angle alpha and beta. So alpha plus beta must be equal to 180 degrees according to rule number 3. We can implement rule number 3 and number drawing. Why? Because we know that PS is a straight line, so if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of the straight line PS at point Q, we have this angle that is equal to 90 degrees plus the missing angle here. In total, they must be equal to 180 degrees according to rule number 3. Therefore, the missing angle here must be equal to 90 degrees. And therefore, triangle PQC is a right triangle. So we will implement the Pythagoras theorem on the right triangle PQC. Okay. So I'll copy the right triangle PQC in a new page, and we'll implement on this right triangle PQC the Pythagoras theorem. PQ equals to 4 units, according to what is given in the question, and we just right now found out that QC equals to 5 units. So actually, this is the right triangle PQC that I copied from the original drawing. Here, by PT is a progression from Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, PC square equals to PQ square plus QC square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 square, that is 16, plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So PC square in total equals to 16 plus 25, that is 41. So we can write here that PC square equals to 41. Okay? PC square equals to 41. In the next step, I will copy the right triangle PAC in a new page and we'll implement on this right triangle PAC the Pythagoras theorem. PA equals to 6 units according to what is given as the question. And we just right now found out that PC squared, that is the square of the hypotenuse, equals to 41. We define the length of side AC as A. So actually, this is the right triangle PAC or PCA. It's a code from the original drawing. According to the Pythagoras theorem, in this right triangle PCA, PC square equals to PA square plus AC square. So I write it down. PC square, that is the square of the hypotenuse, equals to PA square plus AC square. We have already found out that PC square equals to 41, and it is equals to PA square. PA is 6, therefore PA square is 6 square, that is 36, plus AC square. AC equals to A according to our definition, therefore AC square is A square. So in conclusion, we found out that 41 equals to 36 plus A square. Here we subtract 36 from this equation, and finally we get that A square equals to 41 minus 36 is 5. A square equals to 5. We take a root out of this equation, and finally we get that A equals to the square root of 5 units. A equals to the square root of 5 units. Right here in the drawing, that A equals to the square root of 5 units. So this is a semicircle, because of the fact that this is a semicircle, AB must be the diameter of the semicircle. So I write it down. AB is the diameter of the semicircle. We define the radius of this semicircle as x. And because of the fact that the radius of this semicircle equals to x, the diameter must be equal to 2x. That is to say, AB, that is the diameter of the semicircle, must be equal to 2x, 2 times the radius. Okay. So AB is 2x, AC is equal to 5. So what is the length of line segment CB? From the drawing, it is very easy to see that CB equals to AB minus AC. AB minus AC. Repeat again. CB equals to AB minus AC. Again, AB minus AC equals to CB. So CB, this line segment CB equals to AB, that is the diameter, that is equals to 2x minus AC. AC is equal to 5. So in total we found out that CB equals to 2x minus equal to 5. Okay, CB equals to 2x minus equal to 5. So I write it down here in the drawing itself that CB equals to 2x minus equal to 5 units. So in the next step we'll complete the semicircle to a circle, and we'll implement on the circle, we'll do a construction, and then we'll implement a new rule in the circle. So first of all, we'll complete this semicircle to a circle. Completed the semicircle to a circle. In the next step, we will extend QC by a straight line until it touches the circle. Repeat again, we will extend side QC by a straight line until it touches the circle. And we will define the touching point of the extended side QC with this circle as point M. We define line segment CM as B. And we will join points M and S together by a straight line. But before that, I will present to you a new rule, and we will implement the new rule in our drawing. This will be rule number 11. According to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then AO times BO equals to CO times 0. Again, we have a circle. Inside this circle, we have chord AB that intersects with chord CD at point O. Point O is the intersection point of chord AB with chord CD. So according to the new rule number 11, whenever you have in a circle two chords that intersect with each other, then the following equation is true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement the new rule in our drawing. Why? Because in our drawing we have chord AB intersects with chord QM at point C. Repeat again. Now drawing chord AB intersects with chord QM at point C. Point C is the intersection point of chord AB with chord QM. Therefore, we can implement it rule number 11. According to rule number 11, whenever you have in a circle two chords that intersect with each other, then the following equation is true, that AC times CB equals to QC times CM. Repeat again. Now, original drawing, chord AB intersects with chord QM at point C. Point C is the intersection point of chord AB with chord QM. Therefore, according to rule number 11, AC times CB equals to QC times CM. This equation is the implementation of rule number 11 in our drawing. This is equation number 1. AC equals to A and A equals to the square root of 5 times CB. CB equals to 2x minus 5. CB equals to 2x minus square root of 5. And it is equals to QC is 5 times CM. CM, according to our definition, CM equals to B. So in conclusion further, that according to equation number 1, square root of 5 times 2x minus square root of 5 equals to 5b. Here we'll divide this equation number 1 by square root of 5, and we get that according to this equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we'll add to this equation number 1 square root of 5. And we get that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. So here we'll focus on this side of the equation. So we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5. Okay, so we change nothing. And we get that 2x equals to 5b over square root of 5. So here we will multiply square root of 5 times square root of 5, and then we divide it by square root of 5, so we change nothing. And it will be equal to 5b plus square root of 5 times square root of 5 is 5 over square root of 5. In conclusion, we found out that according to equation number 1, 2x equals to 5b plus 5 over square root of 5. I'll repeat again. According to equation number 1, x equals to 5b plus 5 over square root of 5. Here we divide this equation number 1 by 2. And we get finally that x is the variable that we are looking for, because x is the radius of this circle and also semicircle. And our mission is to find out the radius of this circle or semicircle. That is to say, our mission is to find out the value of x. So here we divided this equation number 1 by 2, and finally we get that x equals to 5b plus 5 over 2 times square root of 5. Okay, so we have the value of x, that is the radius of the circle and the semicircle, in terms of b. In the next step, we already joined points M and S together by a straight line. So here we have rule number 5 that we will implement in our drawing. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing, we know that AM, actually here we have peripheral angle MAN. This peripheral angle MAN is equal to 90 degrees. Therefore, according to this rule number 5, peripheral angle MAN that is equal to 90 degrees must rest on the diameter of the circle. That is to say, MN must be the diameter of the circle. Why? Because we have any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Peripheral angle MAN that is equal to 90 degrees rests on MN, and therefore MN must be the diameter of the circle. Okay. We can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS. This peripheral angle MQS equals to 90 degrees. Therefore, according to rule number 5, this peripheral angle MQS that is equal to 90 degrees must rest on the diameter of the circle. Peripheral angle MQS rests on MS. Therefore, MS must be the diameter of the circle. So write it down. Peripheral angle MQS equals to 90 degrees. Therefore, this peripheral angle must rest on the diameter of the circle. Peripheral angle MQS rests on MS. Therefore, MS must be the diameter of the circle. According to rule number 5, because of the fact that peripheral angle MQS equals to 90 degrees, it must rest on the diameter of the circle. MS is a peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle according to rule number 5. If MS is the diameter of the circle, it means that MS equals to 2 times the radius. The radius is x, therefore MS must be equal to 2x. So actually, in conclusion, found out that the length of chord MS is equals to 2x. It is the diameter of the circle. Chord MS is the diameter of the circle, that is to say, MS equals to 2x. Okay, MS equals to 2x. In the next step, we will implement the Pythagoras theorem on the right angle QMS. So I'll copy the right angle QMS or MQS in a new page, and we will implement on this right angle the Pythagoras theorem. QSM. Here by PT is the abbreviation for Pythagoras theorem. QM, side QM of the right angle QMS equals to 5 plus B. Again, QM equals to 5 plus B. MS, the hypotenuse MS is the diameter of the circle, that is to say it is equals to 2x. Okay, again, MS, the hypotenuse MS equals to 2x. The hypotenuse MS equals to 2x. Here, by PT is the abbreviation for Pythagoras theorem. According to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Okay? So, in this right triangle QMS, according to the Pythagoras theorem, this will be equation number 2. MS squared equals to QM squared plus QS squared. Okay? MS is the diameter of the circle, that is to say it is equals to 2x. Therefore, MS squared is 2x squared. And it is equals to QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared plus QS squared. QS is 5, therefore QS squared is 5 squared, that is 25. In the next step, we will substitute x in this equation number 2, by x from equation number 1. According to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Therefore, we'll substitute x in this equation number 2. by 5b plus 5 over 2 times square root of 5. And you get that according to equation number 2, two times x, and x is, according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. So here we have 2x squared equals to 5 plus b squared plus 25. Repeat again. So here we add 2x squared, we substitute x by 5b plus 5 over 2 times square root of 5. So this expression is the value of x. We substitute x by this expression, and according to equation number 2, it is equal to 5 plus b squared plus 25. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And we will get here that 5b plus 5 squared equals to square root of 5 squared is 5, and it is equals to 5 plus b squared plus 25. We'll open the brackets on both sides of this equation, equation number 2, and we get that according to equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b times 5 is plus 50b over 5. That is equals to 5 plus b squared equals to 5 squared, that is 25, plus b squared, plus 2 times 5b is plus 10b, plus 25. So, we focus on this side of equation number 2, and we get that 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b. That is equals to 25 plus 25 is 50, plus b squared, plus 10b. Okay. So here we have 10b on both sides of the equation, so 10b will get cancelled. And finally we found out that according to equation number 2, after we cancel 10b, 5b squared plus 5 equals to 50 plus b squared. Here we subtract b squared from this equation, equation number 2, and we get that according to equation number 2, 5b squared minus b squared is 4b squared, plus 5 equals to 50. Here we subtract 5 from this equation, equation number 2, and finally we get that 4b squared equals to 50 minus 5 is 45. 4b squared equals to 45. We divide this equation by 4, and finally we get that b squared equals to 45 over 4. So b squared equals to 45 is 9 times 5. So we substitute 45 by 9 times 5. over 4. Here we take a root out of this equation, equation number 2, and we get that according to this equation, equation number 2, b equals to the square root of 9 times 5 over 4. Check again, I found out that according to equation number 2, b equals to the square root of 9 is 3, inside the root we left only be 5, and the square root of 4 is 2. In conclusion, we found out that according to equation number 2, b equals to 3 times square root of 5 over 2. According to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Okay? Now we substitute b in this equation, equation number 1, by 3 times square root of 5 over 2. And we get finally that x, that is the variable that we are looking for, that is actually the radius of the semicircle and also the radius of the circle. The radius x equals to 5 times b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. Okay, this expression equals to the value of x, that is the value that we are looking for. So, according to equation number 1, x equals to 5 times 3 is 15 times square root of 5 over 2. Here we multiply 5 by 2 and then we divide by 2. So 5 times 2 is 10 over 2. Here we remove 2 times square root of 5 to the denominator. We take square root of 5 as a common factor from those two expressions. So what is left from 15 times square root of 5 from it square root of 5 is a common factor? What is left is actually 15 plus we take square root of 5 as a common factor from 10. What is left from 10 after we took from it square root of 5 is a common factor? What is left is actually 2 times square root of 5. Why? Because square root of 5 times square root of 5 times 2 in total equals to 10. Okay? All divided by 2 times 2 is 4 times square root of 5. So actually we found out that here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out that x in total equals to 15 plus 2 times square root of 5 over 4. I'll repeat again. Actually we found out that x that is the radius of the semicircle and the circle also, is equals to 15 times 2 times square root of 5 over 4. Here we have in the denominator we have 4. So it is divided by 4. So the radius of the semicircle equals to either 15 times 2 times 4 to 5 over 4 units. In terms of numbers, this equals to 4.8680 units. That is the answer to the question. The radius of the semicircle equals to either 15 plus 2 times 4 to 5 over 4 units, or in terms of numbers it is equals to 4.8680 units. Okay, so in the next step I will summarize the lecture. In this lecture, we found out the radius of this semicircle. Again, this is a semicircle, and we also know that PA, line segment PA equals to 6 units in its length, and PA is tangent to the semicircle at point A. And we also know that line segment PS cut the semicircle at points Q and S, and line segment PQ equals to 4 units in its length. And we also know that line segment QS equals to line segment QC. And we also know that this angle SQC equals to 90 degrees, and this angle PAB also equals to 90 degrees. Again, our mission is to find out the radius of this semicircle. Okay. So first of all, we implemented rule number 10 in our drawing. According to rule number 10, in any circle, if AB is any chord in the circle, and PT, here, AB is a chord in the circle, and PT, tangent PT is tangent to this circle at point T. Point T is the point of tendency. Then the following equation is true. That PT square, that is the square of tangent PT, PT square equals to PA times PB. Again, PT square equals to PA times PB. Okay, we can actually implement rule number 10 in our drawing. Why? Because in our drawing we have, if we focus at point P, PA is tangent to the semicircle at point A, and we have line segment PS that cut the semicircle at points Q and S. Therefore, we can implement here rule number 10. According to rule number 10, we will get that PA squared equals to PQ times PS. Repeat again. According to rule number 10, PA squared equals to PQ times PS. PA is 6. PA is 6, therefore PA squared is 6 squared, that is 36, and it is equal to PQ. PQ is 4 times PS. PS equals to 4 plus QS. PS equals to PQ, that is 4 plus QS. So we substitute PS by 4 plus QS. So 36 equals to 4 times 4 plus QS. So here we divided this equation by 4. (36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtracted from this equation 4 and finally found out that QS equals to 9 minus 4, that is 5. So here QS equals to 5 units. But because of the fact that QS equals to QC and QS is 5, therefore QC must be also equal to 5 units in its length. Okay. Here QS equals to 5, therefore QC also equals to 5. Then we join points P and C together by a straight line. By joining points P and C, we created here a triangle PQC. But here we have rule number 3. It is given us the equation that PS is a straight line. So if we focus on the lower side of the straight line PS at point Q, at the lower side of PS at point Q, the sum of the angles must be equal to 180 degrees according to rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. AB is a straight line. So if we focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha, and this angle that is beta. So in total, according to this rule, rule number 3, alpha plus beta must be equal to 180 degrees. So we can actually implement rule number 3 in our drawing. Why? Because PS is a straight line, so if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of the straight line PS at point Q? We have this angle is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees according to rule number 3. Therefore, the missing angle here must be equal to 90 degrees. So this angle equals to 90 degrees. Therefore, triangle PQC is the right triangle. Therefore, we can implement the Pythagoras theorem with this right triangle, triangle PQC. So I go with the right triangle PQC in the new page, and we will implement the Pythagoras theorem with this right triangle, triangle PQC. This is the right triangle, triangle PQC that I covered from the original drawing. PQ equals to 4 units according to what is given as the equation. QC equals to 5 according to what we have already found out. So according to the Pythagoras theorem, in this right triangle, triangle PQC, here by PT is the expression for Pythagoras theorem, we get that PC squared equals to PQ squared plus QC squared. So PC squared, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, we found out that PC square, that is the square of the hypotenuse, equals to 16 plus 25. 16 plus 25 is 41. So in conclusion, we found out that PC square, that is the square of the hypotenuse, equals to 41 units. PC square equals to 41 units. Then I copied the right triangle PAC in a new page and we implemented on this right triangle PAC the Pythagoras theorem. Actually, this is the right triangle PAC that I copied from the original domain. It is given as the equation that PA equals to 6 units. We define the length of the perpendicular AC as A. So according to the Pythagoras theorem, here by PT is a relation from Pythagoras theorem. Again, PC square equals to 41 according to what we have already found out. Here, PC square equals to 31 units. So according to the Pythagoras theorem, in this right triangle PAC, PC square equals to PA square plus AC square. PC square is 41 and it is equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. AC is 8, therefore AC square is A square. So in conclusion, we found out that 41 equals to 36 plus A square. Here we subtracted 36 from this equation, and finally we found out that A square equals to 41 minus 36, that is 5. A square equals to 5, we took out of this equation, and finally found out that A equals to the square root of 5. Here, A equals to the square root of 5 units in its length. Okay. Then it is given as the equation that this is a semicircle, and because of the fact that this is a semicircle, AB must be the diameter of the semicircle. Okay, AB is the diameter of the semicircle. If we define the radius as x, then the diameter AB must be equal to 2x. Okay, so AB, the diameter AB equals to 2x according to our definition. It's twice as long as the radius, and the radius is x, therefore the diameter is 2x. Again, AB is 2x, it is the diameter of the semicircle. AC is 8, that is equal to 5, so in total CB equals to AB minus AC. Again, AB minus AC equals to CB. AB is 2x and AC is 8, that is equal to 5. So in total CB equals to AB, that is 2x, minus 8, that is equal to 5. So in total CB equals to 2x minus equal to 5. Okay. Again, CB equals to AB minus AC, that is to say CB equals to AB, that is 2x minus equal to 5. So CB equals to 2x minus equal to 5. Then I presented to you rule number 11, and we implemented rule number 11 in our drawing. Rule number 11 talks about two chords that intersect with each other inside the circle. Here in our drawing we have chord AB that intersects with chord CD at point O. Point O is the intersection point. So whenever two chords intersect with each other, then the following equation is true, that AO times OB equals to DO times OC. AO times OB equals to CO times OD. Okay? We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB intersects with chord QM at point C. Repeat again, chord AB intersects with chord QM at point C. Point C is the intersection point. Here we implemented rule number 11 in our drawing. In our drawing, chord AB intersects with chord QM at point C. Therefore, we get that according to rule number 11, AC times CB equals to QC times CM. According to rule number 11, AC times CB equals to QC times CM. Okay? AC is square root of 5 times CB. CB is 2x minus 5, and it is equals to QC is 5 times CM, that is B. According to our definition, CM is B. So in conclusion, found out that according to equation number 1, square root of 5 times 2x times square root of 5 times 2x minus square root of 5 equals to 5b. Okay. Here we divided this equation number 1 by square root of 5, and finally found out that 2x minus square root of 5 equals to 5b over square root of 5. Then we added square root of 5 to this equation number 1, and found out that 2x equals to 5b over square root of 5 plus square root of 5. Then we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to overcome a factor with this expression. So we changed nothing here. And finally found out that 2x equals to 5b over square root of 5. And we have square root of 5 times square root of 5 over square root of 5. Okay, here in the numerator we have 5b plus square root of 5 times square root of 5 is 5 over square root of 5. So in conclusion, found out that 2x equals to 5b plus 5 over square root of 5. I repeat again, we found out actually that according to equation number 1, 2x equals to 5b plus 5 over square root of 5. Here we divided this equation number 1 by 2, and finally found out that x equals to 5b plus 5 over 2 times square root of 5. So actually found out the value of x in terms of b. X is the variable that we are looking for. X is the radius of this circle and also semicircle, and that is the value that we are looking for. We are looking for the radius of this semicircle. That is also the radius of the circle. Okay, so according to equation number 1, the radius x of this semicircle and circle equals to 5b plus 5 over 2 times square root of 5. Okay. It is given, then we completed the semicircle to a circle. Okay. In the next step, we extended side QC by a straight line until it touches the circle. We define the touching point of the extended side QC with this circle as M. Okay. Then, actually, what we did here is we extended the leg QC of angle SQC. Okay, repeat again. we extended the leg of QC by a straight line. Actually, angle SQC equals to 90 degrees. We extended the leg QC by a straight line. When you extend the leg of an angle, you didn't change the size of the angle. Okay, I repeat again. When you extend the leg of the angle, you don't change the size of the angle itself. Therefore, the new angle SQM after we extended the leg QC still will be equal to 90 degrees. Okay? Angle SQM still must be equal to 90 degrees. So here we have peripheral angle SQM that is equal to 90 degrees. And according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. This peripheral angle SQM that is equal to 90 degrees rests on SM. Okay, we join points SM and together by straight line. So SM must be the diameter of the circle according to rule number 5. I'll repeat again on rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle in the drawing, peripheral angle MAN that is equal to 90 degrees according to what is given us in the drawing. Therefore, this peripheral angle must rest on the diameter of the circle. This peripheral angle MAN rests on MN, therefore MN must be the diameter of the circle. Okay? So we can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. Therefore, this peripheral angle MQS must rest on the diameter of the circle. So this peripheral angle MQS rests on MS, therefore MS must be the diameter of the circle. It again, according to rule number 5, MS must be the diameter of the circle, but the diameter of the circle is 2x, therefore SM equals to, or MS equals to 2x. That is the diameter of the circle. In the next step, we implemented the Pythagoras theorem on the right triangle, triangle SQM. So I copied the right triangle, triangle SQM in a new page and we implemented the Pythagoras theorem on this right triangle, triangle SQM. This is actually a triangle QSM that I copied from the original drawing. Here by PT is a version for Pythagoras theorem. Side QS equals to 5 units. Side QM equals to 5 plus B. Here QM equals to 5 plus B. QS equals to 5. And the hypotenuse SM according to rule number 5 is the diameter of the circle that is associated is equals to 2x. Again, according to rule number 5, the hypotenuse SM is the diameter of the circle that is associated is equals to 2x. So according to the Pythagoras theorem, in this right triangle, triangle QSM, SM squared, that is the square of the hypotenuse, must be equal to QS squared plus QM squared. Again, SM is 2x, therefore SM squared is 2x squared. And it must be equal to QS squared. QS is 5, therefore QS squared is 5 squared, that is 25, plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. Here we open the brackets on both sides of this equation, equation number 2, and finally we found out that actually here, according to equation number 2, 2 times x squared equals to 5 plus b squared, plus 25. Okay, this is according to equation number 2, but according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Therefore, we can substitute x in this equation, equation number 1, by the value of x here. Okay, according to this equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Therefore, we substitute x here by this expression. And we found out that according to equation number 2, two times x squared. So this is the value of x according to equation number 1. So we substitute x by this expression because x equals to 5b plus 5 over 2 times square root of 5 according to equation number 1. So it is 2x squared that equals to 5 plus b squared plus 25. Again, according to equation number 2, 2x squared equals to 5 plus b squared plus 25. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2 in this side of the equation, we left only with 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So this expression in total equals to 5b plus 5 squared over 5, and it is equals to 5 plus b squared plus 25. We open the brackets on both sides of the equation. And finally, we found out that 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5 is 10, times 5 is 50. So in total, 2 times 5b times 5 is 50b. All divided by 5. We open the brackets also here. 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b plus 10b plus 25. So here we have 25 b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. That is equals to 25 plus 25 is 50, plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. So in this side of the equation we left only with 5b squared plus 5, that is equals to, in the other side of the equation we left only with 50 plus b squared. So in conclusion, found out that according to equation number 2, 5b squared plus 5 equals to 50 plus b squared. Here we subtracted b squared from this equation, equation number 2, and finally found out that 5b squared minus b squared is 4b squared. So 4b squared plus 5 equals to 50. Here we subtracted 5 from this equation, equation number 2, and finally found out that 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. Here we divided this equation, equation number 2, by 4, and finally found out that b squared equals to 45 over 4. B squared equals to 45 over 4. We substitute 45 by 9 times 5. So b squared equals to 45, that is 9 times 5 over 4. Here we took out from this equation, equation number 2, and finally found out that according to equation number 2, b equals to the square root of 9 times 5 over 4. The square root of 9 is 3, so inside the root, the square root of 9 is 3 and the square root of 4 is 2. So in the numerator we left with 2. So inside the root we left only with 5. In conclusion, found out that b equals to 3 times square root of 5 over 2. This is according to equation number 2, but according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times root of 5. Okay, so the next step we substitute b in this equation number 1 by 3 times root of 5 over 2, and found out that according to equation number 1, x equals to 5, and b is 3 times root of 5 over 2, plus 5 over 2 times root of 5. 3 times 5 is 15, so in the numerator we have in total 15 times root of 5, plus 5, here we multiplied 5 by 2 and then we divided by 2 in order to have a common factor with this expression. So it will be 5 times 2 is 10 over 2, and then we moved the denominator 2 times root of 2 here, so in total we get that it will be 2 times root of 5. Okay, so in the next step we took root of 5 as a common factor from the numerator. What is left from 15 times root of 5 after we took from it root of 5 as a common factor? What is left is actually 15. What is left from 10 after we took from it root of 5 as a common factor? What is left? It's actually 2 times root of 5. Why? Because 2 times root of 5 times root of 5, in total it is equals to 10. All divided by 2 times 2 is 4 times root of 5. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out that after we cancel square root of 5, that x equals to 15 times root of 5 over 4. Okay, so the radius x of the semicircle equals to either 15 plus 2 times root of 5 over 4 units, or in terms of numbers, x equals to 4.8680 units. Repeat again, the radius of this semicircle equals to either 15 plus 2 times root of 5 over 4 units, or in terms of numbers, the radius x equals to 4.868 units. Okay, thank you very much.